It should start now. Yes, pretty easy. Yeah. So let's start with discussion div to a larger subsequence. You're given a string containing only A's and B's, and a good string is somewhere where the occurrence of AB as a substring is equal to the number of BA as a substring. Okay. Huh. So now main thing is you're given a string, find the longest subsequence such that the string is good. Okay. So now let's take an example. B, A, B, A. Okay. Now, if I take this entire string itself, and let's say I take this entire string as a, let's check if it's good or not. Okay. This is, we'll have two counts, A, B and B, A. Okay. This is one, so I add a one. This is B, A, so I add one here. This is AB, so I add one here. This is BA, so I add one here, and this is another AB. So now here you see, this is more. AB is more. Okay. Now the why is it more? Because at the end I'm having a B, right? Either I'll remove this B or I'll remove these two A's to reduce the count of ABs, right? Yes, no. Be responsive, people. Hello.
से एक्टिंग बंद
Yes, no, bol do. Hmm. So basically, if I just remove a B here or these two A's, then I'll reduce this count by one and I'll have these things equal, right? Same goes for this. Let's say it is B, B, A, B, A. Now here A, B, B, A, let's just count. B, A, B, and 170. Now BAs are more, right? So either I'll remove this A or I'll remove the starting B's. Yes? So if I remove these B's or I remove this A, then I can get this. So more formally, like you can try the removal technique also, but a very easier and a cleaner way is a good string should start with an A and end with an A, always. Why is that? Because then it'll all cancel out. If there is a B in the middle, then there'll be another A to cancel it out. So that is my claim. Do you understand? Like the starting and the ending character in the subsequence or the substring should be same. Yes, no. Then I can say it's a good. Same goes for here. If I start with a B and end with a B, I'll get a good string. And if I start with an A and end with an A, I'll also get a good string. Does it make sense? Because what is happening is, let's say I start with an A. In the middle, whatever it is, if there are all B's, this AB will be cancelled out with this BA. Okay. Let's say this was an A. This AB will be cancelled out with this BA. Let's say both were A's. Let's say both were A's. Same thing, these two will get cancelled out. If only one B was there, still the ABs will get cancelled out. So my main logic is both these numbers, like both these indexes in my subsequence should be same, first and last. So how do I get the longest string? Pretty simple. I get the first occurrence of A and last occurrence of A, first occurrence of B, and last occurrence of B. This I get by min max. Pretty simple stuff. And then I get this entire substring only. Like, since I only need to care about these two characters being the same, let's say I have the first A and last A. I'll take this entire string only. No, why am I caring about subsequence? I'll take this entire string. So that entire string is basically my index of the last A minus the index of the first A plus 1, because let's say first A is at 1, last A is at 2, 3. So my length is basically 3 minus 1 plus 1. So that's it. Wait, huh. So max minus min plus 1. Same goes for B. I can have B also as a start and end, right? So whatever the max is, just print that. Any questions, any doubts?
So what I did was in like I'm sharing my approach that if a character is equal to the first character, then we can take the maximum of the current length and the distance between the
Yes,
current index plus one.
yes,
If the first character and ith character is equal, and if the
fair,
ith character and the last character is equal, then we can do an n minus the current index.
fair.
As
So, so what Rajdeep is doing is something iterative, but same thing. So let's say I have this. Okay, I iterate like this. If this character is not equal to this, but it is equal to this, so I check this is a valid window. So I keep it as max of the answer. Then I check these two. It's still valid. So I like this can be my answer. Let's see whatever it is. Then we check these two, and these two once. Like these two once. So it's the same thing as doing min max, but it's just iterative. That's it. Hello. So then let's come to sort smaller. Viram.
Ah, so coming to Zor smaller, what you are said is you are given a few numbers. You have to find all the x. Please mute yourself.
Yeah, yeah, mute.
Thank you. Huh. You have to find all possible x such that AI for all I, right? A of I, Zor x is less than A of I. Okay. So how do I achieve this? First thing is there is an finite number of x always. Why is that so? If my x is greater than ai, then a of I greater than ai in the sense, let's say this is my ai, some bits set, and my x has a bit set over here. So the maximum, so this bit will be set in my final value of ai's or x, right? And it will be greater. So there is always a finite answer possible, which has to be somewhere here. My MSB of x has to exist. Now let's see. I have a value x and I have a y, and I want to find all such x such that x or y is less than y, just for a single number, right? So how do I do this thing? Y is has some binary representation, and let's say it has a few bits set here, here, and here. Let's say here this is a 0, this is a 0, and let's say I have a bit set here. So one thing one claim that I can make is that the MSB of x has to be set in y. Why is that so? So let's assume this is the MSB of x. I have it set over here, right? So that means there will be some sort of a zero, right? Some sort of a zero that will turn to a 1. So at any point, if I have a 0 in my y, I can't have my x set. Okay. So now I need to find this x for the whole array. So if at any point, so the whole array, if we just put in as bits, right? So you can get it in somewhat this way, where this is the 0th bit, this is the first bit, this is the second, this is the third, and here is the fourth. So even if any one of this is a 0, right? And rest all are 1, I can't have my MSB of x over here, most significant bit of x over here. So for this, what I need to do is, you can guess that if one of them is 0, all of them are 0, we just AND all of our values. We just get an and we have our final number. And after that, let's say this bit, the ith bit, 0 based indexing, ith bit is set. So like in x also my ith bit will be set, and rest all bits I can have any combination, right? So there will be I bits left apart from this one if this is the ith bit. So my 0 based indexing. So my answer will be 2 raised to I. So what I need to do is I need to take AND of all these. I get a one final number. If a bit is set, so we just do 2 raised to I. That's it. And we add 2 raised to I to our answer. And coming to the code, let's just write it. It's stdc++h. Uh, Here we have solve function. We have input of n. We take input and we just take input of the first number. We just name it A, C in A. And now we take input of rest of the numbers. X is equal to 0. So I'll just take input of x and x and sorry, a and equals x. We just found the and of all the numbers, and now we need to make an answer. So for that, we'll just iterate. Our max power will be 30, right? So let's just iterate until 35 just for safety. I less than 35, I plus plus. If uh, the bit in A is set, then we add the 2's power to our answer, right? That is what we are
For loop,
doing, and
sir, for loop.
we print our answer.
Int I equals.
Huh. So this is how you
सेकंड
can.
फॉर लूप कर रहे हो ये बस प्रिंटिंग ए से नहीं हो जाएगा
Hmm.
That's just
Huh?
printing.
जस्ट प्रिंट ए ना मतलब एडिंग द सेकंड पावर ऑफ एडिंग
That
2 to
is
the power
AI.
of i is
Oh, wow. Yes,
Yes.
that just. No, but I am adding the previous power.
Huh.
you're not adding the previous power you're adding the same power
Oh,
You're
huh.
adding the
Exactly. Wow. Yes. You just print a better. Yes. Submit.
मेरा इसके लिए कोड देखो बहुत छोटा था
Yes.
गेस फोर्सेस बट स्टिल
AC. People, any doubts?
wait,
Hello?
infinite loop.
No doubts. Okay. Bye.
How does this work for phi?
Uh, 5. Okay. So 5 is 101. Right. I need to find all numbers. So this is a 1. So I have a 1 here. And I can have 101. Sorry. Rather a 00, 01, 10, and 11. Basically 2 raised to 2 numbers. Right. And same thing with a 1. And rest all ahead are zeros, and that is how you, and I can have nothing. So that's just a single one. Basically 2 raised to I power. Exactly. Understood?
So, okay,
Hmm.
understood.
Okay. Bye bye.
Yes. So then let's move on to mul2. Okay. Yeah. So in mul2, you let me read. Given a for every prefix, right? Yeah. Let's just take this example. Next. Okay. So in this question, firstly, the score of the array. Okay. It mentions score, right? F of A, whatever. F of A is basically now given this array. I'll just remove two pairs which are the same number and I'll add 2 into A of I. Like I'll be removing these two and I'll adding 2 into A of I, which is 4. Same goes for these. 1 and 1 I'll take, I'll combine and I'll make a 2. 2 and 2 I'll take, I'll combine and make a 4. Now 4 and 4 I'll take, I'll combine and make an 8. The numbers I'm left with are 8, 3, 2. Okay, now I can't do any operations, right? So this is my final array and my f of A is basically size of final array. Final array. Okay. Now let's try for this specific only, then we'll come on to the prefix part. Okay. Okay. How would we code this up? Like, how would we even imagine? Firstly, let's just put all these numbers in a set, right? Set or a map. Set, let's do it. So let's put make a set. Let's put a 4 here. Okay. Then let's put a 2 because 2 is not in the set. Now when I try to put 2, 2 is already in the set, right? That means I can match this 2 with a previous 2. Where I have it, when I had it, doesn't matter. I have a previous 2, so what I'll do is simply I'll remove this 2 and I'll make it a 4. Now I'll check once again. Is 4 already there? Yes, 4 is already there. So I'll remove this 4. I'll make an 8. And now I'll have an array and I'll add 8 to the set because 8 doesn't exist here. So now my entire set becomes this after I've reached here. Okay. Now same thing, I'll add a 1 here, then I'll add a 3 here, then I see 1. 1 is already there. So I'll remove a 1, I'll make a 2, and I'll add it. So does it make sense? Like how did I calculate for this particular thing? Like how did I get the final array? Yes, no. And final array is just this size of this. This is my answer. F of A. Yes, no. Hello.
Yes, yes.
Yep. So now, yeah. And in this method only, while I was doing this, This was I did for a particular array, right? Now I need to calculate for this, for this, for this, for this, for this array, and for this array. We technically just iterated, right? And we had the final array at every single step. Yes, no? We had this set, no? For every single iterating index. So we just print those answers out. So firstly, when we had a 4, this is my 1 comma 1. Then I have 4 comma 2. This is at 1 comma 2. Then I made an 8 here. That was at 1 comma 3. And so on. Then you have 8 comma, like so on, basically. Now, while we were iterating only, we just print these answers out. Print the size of the array, size of the set, every single time. The algorithm remains the same, but we're just optimizing it. We're not calculating for every single thing separately. We're just calculating it while we're iterating only. So that's just the modification. And yeah, let's just see the code. Firstly, I take the input and I make this set. Okay, take the input, I take the set. Now, for every index, we have a number which is the current number a of I. Wait, this is not needed here. While my current number is in the set, what should I do? I should erase the number and I make number times 2. And at the end, I'll add the number, right? That's it. We just print this number out and we get and we submit. Any doubts here, like how this magic thing is working? Hello. And yeah, one more thing. People might see that this is one for loop, this is a second for loop. It might go n square, and that is wrong because like n square will not work because n is less than like yes, n at max can be 2 like 10 raised to 5 and n square becomes 10 raised to 10 which is greater than 10 raised to 8 which will give you TLE. Okay, but now why won't this give TLE and why is it always working? Okay, so now let's see now what is happening. At let's say I have a set size of 1e5, 10 raised to 4, okay, after a particular index. Now let's say after I'm adding the 10 raised to 4 plus 1's number, I am removing all the numbers from the set. Let's say I'm removing 10 square numbers from the set. Okay, I'm removing. So the set then becomes 1, 8 into 10 raised to 3, 9 into 10 raised to 3. What? 9.9 into 10. That is 9 into 10 raised to 2. 99 into 10 raised to 2. So this is just like at max, like how many iterations I did? I did 10 square iterations over here, right? So that is my while loop. This is my while loop. In the next one, let's say I do all these numbers and the set size becomes 1. So like more formally, what is happening is like this is just intuitive way that whatever I'm increasing, whatever I'm adding, some like I'll remove once only, no? Let's say I have 10 raised to 5 numbers. I add all numbers and let's say at the last I'm subtracting all numbers. So what is happening here? My while loop ka pura sum, like at the end what is happening is 2 times I'm iterating, right? So it's not n square, it is 2 into n, because what I'm doing is adding numbers, let's say all the time, and I'm subtracting numbers, removing numbers some of the times. Let's say I'm removing all the numbers from the set. That means I've added them sometimes, I've subtracted them sometimes. Total at max I'm doing 2 into n operations. So that is why it is 2 raised 2 into n. And this set dot find, since it's a ordered set, it takes log n. So my time complexity is 2 into n into log n. And this will pass. Okay, any doubts why this for loop is working, double for loop, and this set logic, and just printing the answer? Any doubts? Just write it on chat, wherever you want. Okay, I'm assuming there are no doubts. So let's come to buying game. This is probably like this was initially a very easy problem. Like this was initially div 2b, but by solves it just became div 2d. So yeah, there is a very small trick to this, but very good trick. So now, yeah, I'll just have this. Yeah, this is my array A. This is my array A, and this is my array B. The question states at every day, every I am buying a ticket. Yeah, I'm buying a toy, buying an item. Okay. I am buy one thing, one item. Okay. And I have two costs. Okay. If if the item equals I, then cost is B of I, or else it is cost is A of item, whatever item you're choosing. Okay. And now you need to figure out what is you must buy all the items. Find the minimum possible cost to buy all the items. So now a very brute force way is know everything. So a very brute force way is for every index, I do another loop of j, and I just basically get ki For this I am buying this j, and for every I comma j I make a pair and I get the cost and I get the minimum cost. That is what I'm doing is n square. Basically, if I'm at a current day, all the possible items left, I check. Let's say J1, J2, J3, J4. Then I go on to day, the next day, the next day. So this is basically not even n square. This is too much. So what is happening is for every day, I'm going for n numbers of items, and it is basically going n raised to n into n factorial, basically. If you do it recursively, dp, whatever. So this is like too big of a number, and my n is given here. It is 1e5. Now 2e5. Same thing. N square will not work. So this will definitely not work. So there must be a smart way. Okay. There must be a smart way of choosing. And how do I choose? So let's come to the smart way. Now, what does your like? Firstly, if my BI is less, if my BI is less, so I'll try to choose this. Na, I'll at this index, I'll always choose this. Why would I choose something else? Like there is a edge case, but yeah, does it make sense? Okay, if I'm at an I and my BI is smaller, so I'll choose that BI. No, I'll choose that item itself. Why would I try to choose something else? Fair? Yes, no. Same goes for here. If this is equal, why would I choose something else on this day? Here I will try to choose something else. Okay. But all these days I'm choosing the same, right? Yes, no. Hello.
Yes.
Yep. So now let's create a better like example. 1, 2, 3, 4, 5. Let's put 4 here, a 1 here, a 2 here, a 3 here, and a 8 here. Okay. So what do we see here? These days, I'll be taking this number itself. Yes. Remaining days are what? These 2 days? Yes, no. Hello.
Yes.
Huh. So these cost I take. Now for these 2 days, what I'll do, for this day I'll buy this one. At this day I'll buy this one. So I can basically take 1 and 5, right? Yes,
Yes.
exactly. So that is what we need to do. But now the thing is, and if you want to calculate this cost, if you're just directly doing this, you take the minimum among these two. For every I take the minimum. Yes.
Yes.
But now there's an edge case. It is in the test case itself, but yeah, this one. Now you see that you fix this, okay? You take this on this day. But now for on this day, you have to take this. There's no other option, right?
Yes.
You have to take this. So my cost is 2 plus 1 instead of 1 plus 1. Correct?
Yes.
Yeah. So now you see that if my after I'm pairing that I'm taking the minimum, I'm taking the BIs, like this pairing, where BI is less than AI, less than equal to, I check how many numbers are here, how many indices are remaining. Okay. Why am I doing that? Let's say it was like this, 5 0. So I'll choose this also. This is a solo person, right? So I'll have to take this as BI instead of AI. Yes, no?
Yes.
Yeah. But now there's an edge case here. This people might not have thought of. People were like, most people would have struggled here only, and that's why there were less solves. But if I have only one, okay, the cost of me taking this is 4, right? Yes.
Yes.
But if I don't take B of I here and I take these two here, then what is my cost? 3. Basically, even though my BI is lesser, I'm still choosing this AI, and I'm still choosing this AI. Yes,
So we are choosing the minimum difference.
exactly. So I'm choosing the minimum difference. And which one I'll take? I'll choose the minimum difference, right? So that I am not hampering the, like, basically, even if I choose it, it's like the best I can choose. That's it. Yes, no. And yeah, not always you choose the minimum difference also. Let's say it was this 1 2 and 4 0. Here I would rather take 2. I would rather take these two than these two, right?
Yes.
Exactly. So now I just have to take the minimum. I take this or I take these two. That's it. So like let's come to the code so like you understand thoda. I've written it so that it's very readable. Yeah. First let's take the input of AI BI, A and B array. Fair. Now for every number, if my BI is less than equal to AI, I'll take this difference. If this difference is lesser, so I keep that in store. Basically, this one, 2 2 1 5 0. Two ones difference is smaller. So that's like that is what I'm doing with this minimum. And I'm taking the cost as BI. Okay. And for all remaining, I'll push them in an array. Okay. Till now, does it make sense? Like all the numbers lesser, these indices, I'll do this thing. This is my part where I store the minimum difference and I add BI to my cost. For all the others, I just push back to my remaining index. Like this index and this index go to my remaining. Now, if my remaining vector ka size is 1, that is like, if it is not 1, what do? I'll take all the AIs, right? Basically, if I have 3 remaining, what I'll do? Let's say I have 1, 2, 3. I'll choose, I'll choose, like basically, I'll choose 2 on the first day, 3 on the second day, and 1 on the first day. So basically, cycle 1, like cycle 1. So that I can satisfy always. If I have 4 also, I can just do this 2 1 2 1 4 3 also, or 2 3 4 1 also, whatever you want. So here I'll always take the AIs because that is a lesser one. Only thing is the else case. I'll either add my remaining ka bi, yes, or I add the ai of the remaining and take the difference, the minimum difference. That is my penalty, right? Yes, no. Hello.
Can you explain the edge case again?
Yeah, yeah. So now let's say I have 482197. Just a minute, okay? Um, um, हेलो हाँ बोल हाँ ઘરે છું ના હું નથી આપવાનું હું મારું કામ ચાલે Oh, I didn't do my content. Okay, fair. Is am I audible?
Yes.
Okay. So now let's say this is my array. Okay. Let's keep it 9721. Okay. These are my lesser numbers. So I'll take this.
Yes.
Yes. Like my BI is lesser than AI. So I'll take these numbers directly. Yes.
Yes.
And my minimum difference is what? This one.
1.
My minimum difference. Okay. Now, since I have only one remaining, what are my two cases? Either I'll take this. Yes, I take this directly.
Yes.
So that is my B of remaining of a 0. Yes,
So the minimum was day was already occupied, so we took the minimum.
exactly. My day is like I have to buy something here, right? On this day. If I buy this item only, I'll have to pay this, no? Yes.
Yes.
Huh. So either I'll take this or I'll buy something else on this day and on the other day I'll buy this. Basically, on this day I'll buy 2 and on the other day I'll buy 4.
Yes.
Yes. So I'll take this like AI, so I'll have no A of I.
Yes.
And in my cost, I've already taken this. So what is my increment? It's just by B of I, no? Like by the difference, right? Fair. Like in my cost, I've already considered A of I, B of I to my cost. But now since I'm not taking this, I'm choosing an A of I, right? And what is my difference? Difference is A of I minus B of I. So that I'll add. So this is the minimum difference. And this is my A of that index. Does it make sense?
Yes.
Exactly. So that's it. And then you just print the cost. Any doubts?
Can this be done using two priority queues?
Priority queue, this can be done. There are lots of ways to do this. Like you can sort it with respect to the difference and then go
I
about
tried
doing
once.
it. But it's like,
Can you check my code?
okay, wait. You are in div
1. Oh, sorry.
4, no?
Last day, 4, 4.
Yes. D. What is your ID?
I have not submitted it in the contest. I have
Okay.
Just a second.
Let's just debug after I solve the next question. So I'll end the stream and then we'll debug. Okay. Is it fine?
Okay, no problem.
Cool. So now let's come to the maker tree. Yeah, this is a very interesting problem and a very good problem, like implementation based problem. Okay. So now this has a lot of uh like like this. You might read it. If you haven't read it, just read it once again. We initially have a graph with zero edges, and we'll be performing coloring operations. In each operation, we choose an array C, which has colors, and we do this. For all I comma j, if Ci equals Cj, we add the edge. If it is not already existing, and then we convert the graph. And we want to make the graph to the given tree. Okay, a tree is given with the edges, and by this operation, I want to get the graph, make the tree. Okay, and how that color operation is also working, I'll explain it. Okay, let's say this is a tree I want. Okay, this is my need. A coloring operation, will you make three colors the same color? Firstly, three nodes the same color. Let's say I make these three nodes the same. I'll add this edge. I'll be adding this edge, but I'll be adding this edge also, right? Which I don't want. Okay, so I'll never make three edges the same color. Okay, so if I'm not making three edges the same color, what is the minimum amount of time? So let's just do this now. Let's say yes, I want to make this edge. Okay, since I can't have a 1 here, I have to have a 2 3 here. I can't have a 2 also here because then these two will get connected. Same thing, I can't have a 1 here because I've already had a 1 here. Oh wait, yeah. So I have a 4 here because 2 3 will connect these two nodes. Now I can have a 4 here because 4 doesn't have a pair, right? So this can be one of my colors, like starting colors. And what will this do? It will add these two edges. Yes, so my array becomes, let's say this was 1, 2, 3, 4, 5, 6. Okay. If this was the case, what is happening is my array becomes 1, 1, 2, 3, 4, 4. Okay, this is my first coloring array. Okay. So after my first coloring array, what is happening? I need to do it once again. I need to color them once again. I have just made these two edges, right? Now let's say I want to make these two edges at this edge. So I have one, I have a one. Now two, three. Now this edge is not there and three is not there, so I make a three also here and a four. So these two edges are made. Okay. Now same thing. Now last edge is this. So I make a 1, 1 here, a 2, a 3, a 4, a 5. Okay. So this edge will also be made and then done, right? Like I made the entire tree. Any doubts here? Okay. People have just left, but okay. That is how you do it, but yeah.
Correct.
Now, how do I do this? How do I code this? This is the visually I can say, na, कि bhai, first let's make these nodes, then make these nodes. But how will the code understand this? That is also a challenge, right? So I'll just show you the code and then it's just be explainable through that only. Yeah. Yeah. Let's come to VS Code. Tree. Yes. This goes away. This- Okay. So now firstly what I'll do is I'll make the tree. Okay. And I'll have a set of edges made. Because at the end, if I have n minus 1 edges, that means I've made all the edges. Fair? And my starting color is, let's say 1. Actually 0. Wait. Someone is at the door. I'll just come. Hide this. Okay. I'm back. I'm back here. Okay. So now I made the nodes and I'll have a starting color, whatever it is. And I'll have an array of colors. Like that is what I need to print basically at the end of it. Now, while I have not, like while my edges size is less than n minus 1, I set all my colors to 0. Starting color is 0 and I do the DFS. After I've done the DFS, I just push it back to my answer and I just print the answer later. Okay. But now how do I do this DFS and what is the smart thing about it? Because at the end of the day, this part is like very easy. No, this is like normal DFS. But how does it get the actual answer correctly? Always is a question, right? So now, yeah. Firstly, if I haven't made this edge, like if my current node is not a part of an edge, then my flag is 0. Like flag is 0, right? Like basically, I can make it a new edge. What it means is, let's say this edge is done. When I'm at this node, this is not part of an edge, right? I have not colored this up. If I have not colored this up, let it be 0. That is my flag. Okay. And wait. Hold on. What am I doing? Damn, man, how is it working even? Okay, cool. This means that I have, wait, one second. Okay, one second back. Okay. So now flag equals 1 signifies that this node is not part of an already made edge. This node is a part of an edge. Already made edge. Yeah, that's right. Okay. So now basically what is happening is when I'm here, okay.
You're on mute.
Oh wait, yes, I'm back. Huh. So now let's say I want to make this edge. Okay, this edge I want to make. What I'll do is I'll color these two nodes one. Okay. Now when my DFS comes to this node, since my color is already one, can I make another edge here? Or a here? Or here? No, right? Because if it's already preset, that means I have made an edge with my parent currently. Yes, no? Does it make sense? But yeah. So like that is my flag variable, that my flag is 0. If I have already colored this node, like the parent has colored this node, so I can't make a new edge with my current node. Okay. But if my color is 0, that means my parent के साथ the edge has not been made. Then what I do, I assign my color, no, assign the current color to the node, like plus plus, because I want a new color, and I set flag to 1. Now for every child of my current node, if it's a parent, I do continue. If flag is 1, what does that mean? That I'm yet to make an edge. Like I have to make an edge. Like this is my node is not part of an already made edge. So I can make an edge, right? With my child. That is my flag. And I see that if my current edge node to child is already not there, if it's already not there and I can make an edge, so I make this edge. I color my child to what my color is, and I set flag to 0, because in the other childs I've already made this edge. So basically, let's say I made this edge, right? Now I can't make this edge, right? So I set flag to 0 so that once again I don't make this edge also. So that's it. And you do DFS to the child, and else also you do DFS at the child. Cleaner code will be this. So yeah, that is just the DFS. And yeah, I'm using this auto and self. It is basically C++ lambda functions. Why am I using this? Is because I don't want to pass edges made. I don't want to pass colors. I don't want to pass adjacency list at every single DFS call. It makes the entire length too big. Or else you make this. Na? Normal thing is you do this. Void node parent and adjacency and color, and you have your set of the edges. This is like too big of a statement to even write and then pass every single time. So this basically auto DFS basically keeps the variables mentioned before as global for its context. And why am I using auto and self? This is basically a lambda function. It is completely different from the normal std function. Basically, like it's very fast. It's faster than std function. So always try to use this. And yeah, this is the code. Any doubts if you have? Viram, same approach or different? Viram is hello.
हेलो 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 यस
Viram,
यस आई एम
same
देयर
approach or different?
क्या थी अप्रोच मेरे को मैं सुना नहीं
अरे
मैं
नहीं, same code or different?
अरे पर मैं मंदिर गया था भाई
Oh, बीच में क्या
अभी
अभी?
आया हूँ
Oh,
नहीं कब का like full middle part
okay,
में
okay,
गया
fair.
था. It's
Hmm.
more complex.
This is just
दो
DFS
दो
and you
तीन
just
दो
do.
PFS हाँ नहीं हाँ एक ही ना
Take
हाँ
it
it's
easy.
more complex.
Very elegant.
हाँ mine is more complex सही बात है.
If you want the codes, we'll be sharing on LinkedIn
What?
editorial.
Only 62 people did.
Yeah, in Div 2, yes.
15 ranked.
In Div 3, only 4 people did. Damn.
Wow, we're top four. Magic.
Wait, let's do Div 4, no?
एक मिनट updated rating please. अरे नहीं codechef.com/ratings.
Did it get updated? It hasn't updated.
No.
But I'm probably beating you, guys.
Hmm. A यार bug
I would have
A.
gotten this, I would have maintained this, but I went on solving this. Like I got the approach, but like I coded this entire thing and then realized something where it is not working.
Oh.
Just scrapped it and I went on to this. Or else like when I saw this, I got this approach within like 15-20 minutes.
हाँ
Easy top
that
40. Global warming is interesting. Okay. Let's just say bye to the stream. Like, share, subscribe. Ask doubts on Discord. Join Discord.
also
Join
use
community.
bot.